Hello everyone, this is Dilip Chakravarti from IIR Engineering College. Today we are going to discuss about stacks. So far we discussed about linked list and definition of data structures, and we have seen classification of data structures. Let us discuss about stacks clearly. Stacks. What are stacks? Stack is a linear data structure where insertions and deletions takes place at one end. What is this linear data structure? So we all know that data structure is nothing but it's a the way of organizing the data and the set of operations performed on the data. Now, how we are organizing, how we are placing the data. So data structures, they are classified into two types. So one is linear data structures, the other one is non-linear data structures. Linear data structures where data is organized in sequential fashion, whereas non-linear data structure means where data is organized in hierarchical fashion. Okay, we are not following any sequence there. So we are not placing the data one after the other in non-linear. Whereas in linear, we are placing the data sequentially. Okay, so we have seen a lot of examples of linear data structures such as stacks, queues, linked list, arrays. So now let's see about this stack. A stack is a linear data structure. So what are the operations we are going to perform on this stack? We can insert or we can delete. So where I am going to insert? So I'm going to insert and delete at one end. Okay. If you observe this, this is the diagram of a stack where we are inserting and deleting at one end. We are calling that end as top end. So I can push one element. So here in stack, insertion is called as push, whereas deletion is called as pop. So whenever you are trying to insert an element, whenever you are trying to push an element, you are pushing it from the top. So it will come here. Then you will push one more element. Then you will push one more element. Similarly, whenever you are trying to delete or whenever you are applying a pop operation, so we are deleting it from the top only. Okay, that's why we call it as we say it as so where insertions and deletions takes place at one end called as the top end. So what is the principle we use here? So we are using a principle called LIFO, last in first. Whichever element which enters last will be removed first. Okay, whichever element which is entering last will be removed first. Okay, we will see clearly about this. Okay, fine. What are the operations we are going to perform on stack? So here we are applying, we are going to use lot of operations on stack such as push, pop, peek, is full, is empty. Okay. What do you mean by push? Push is nothing but insertion. Okay. We are adding an element into the stack. Push means we are adding an element into the stack. Okay. So okay. So pop means we are removing an element from the stack. Okay, so here peak means whatever is the element which is top, we are going to it will returns the top element from the stack. Is full means it checks whether it is full or not. Okay, so is empty means whether stack is empty or not. Okay, we won't talk about queues here. We will just see about stack where we are going to insert an element. The insertion we call it as push, and the deletion we call it as pop. We'll see one by one. And before going to see about the operation, so how we are going to represent this stack? Representation of stack. Stacks can be represented using two forms. So it may be array representation or it may be linked representation. I can use either array representation or linked representation. What is this array representation? How we are going to represent a stack using arrays? So we all know arrays are nothing but it's a collection of homogeneous elements. Okay, so here also we are collecting all the elements in a array fashion. Okay, observe here uh, let us consider a stack with 6 elements. Okay, so we'll take 6 elements. The capacity of stack is 6. The number of elements to be added should not exceed the maximum size. So we are going to add first element, second element, third element, like this. So whenever it reaches to the 6 elements, so after that, if you are trying to insert the element, so we'll get a condition called overflow condition. So as a stack already is filled, it is already full. That's why we'll be getting a condition called overflow condition. Similarly, so we can delete the elements. We are deleting the elements from the stack. We are deleting one by one. So if stack is empty, if you are trying to delete again, so then you will get a condition called underflow. It is saying that nothing is there. So overflow is nothing but it has already reached to its maximum size. Underflow is nothing but it no more element is there in the stack. Okay. See the algorithm. For pushing the stack. So we have written some steps for how to push a stack, how to push an element into the stack. So here, this is the procedure. The first instruction is stating that I'm checking whether it has reached to the maximum size. As I already told you, if there is space only, I can insert an element into the stack. Okay, so I can insert an element at top end only. Okay, whenever you are inserting, top will be incremented. Okay, so when top reaches to the maximum size, if you are trying to insert, you will get a condition called overflow. Okay, that is what he is saying in the first statement. First, we are checking whether top is already at maximum size. Top is already at maximum size means stack is full. Okay, you will get an overflow condition. Otherwise, so what we are going to do? We are going to insert an element at the top of the stack. Set stack of top equal to item. Whatever the element we have taken, we are placing at the top of the stack. Okay, and top will be incremented. Earlier top will be at one position, then top will be incremented to the above position. Okay, this is algorithm for stack. We'll see with example here. Let's see, this is array representation. So this is a stack which can hold up to 6 values. Okay, so as we are using array representation, it starts with 0, 0, 1, 2, 3, 4, 5. Okay, so initially my top is at -1. If nothing is there in my stack, if stack is empty, so top is -1. Okay, so then what I need to do? I need to push an element. Okay, I'll be pushing, so it will be stored at 0. Okay, so push 21. Observe here. I am pushing an element 21. So I pushed here. So earlier it is nothing is there. Top is at -1. After pushing my element, top comes to here. Okay. So here I said one more operation, peak. Peak means, so what is the element that is present at top of the stack? Okay, it gives you the element which is present at the top of the stack. Here top of the stack is 21. Okay, so that's why peak element equal to 21. Okay, next again I am trying to push one more element 15. So my top comes to here. So earlier top is here, then top is incremented. Okay, peak element equal to 15. Similarly, I am going to insert all elements at second position, third position, fourth position, and fifth position. Okay, I'm pushing 13, 24, 11, 35. So it comes here. So now top come to here and my peak element is 35. Okay. Now, if I am trying to insert one more element, if I am trying to push one more element, what happens? As top reaches to the maximum size. So already top is at position 5. That means six elements are already there. Stack is full now. So we will get a condition called stack overflow. Okay. So if you are trying to push 51, so we'll be getting something overflow condition. Okay, as top is pointing to the last element of the stack, so we'll get an overflow. Okay, is that clear? So that is about push. Okay. Similarly, let's see pop operation. So pop is nothing but deleting an element from the stack. Okay. So we are going to delete an element from the stack. So this procedure deletes the top element of the stack. So as I already told you, insertions and deletions, they are taking place at one end. Okay. I'm going to insert here only. I'm going to push here only. I'm going to pop here only. Okay. So which is what we call it as top. Okay. So now I'm checking before deleting if already stack is empty. If already stack is empty, if I'm trying to delete, so I'll get something called underflow. As nothing is there in my stack, I'll get something called underflow. Okay. If elements are there in the stack, I'll just pop that element on the top of the stack, and top will be decremented to the next position. Okay. See here. If top equal to 0, so top equal to 0, when I am going to get, so if nothing is there in my stack, okay, if nothing is there in my stack, so then I am just printing underflow. Okay. And I'm just coming out. So if elements are there, in the stack, so what I will be doing, I'll just delete that item in the delete that item from the stack. Okay. So stack of top will be deleted. That will be the item. Okay, that will be the element. So the next step is what I need to do. I need to decrement my top. So earlier top will be here. After deleting 11, top comes to here. Okay. So earlier, if you observe here, 35 is there. After deleting 35, so top comes to here at 11. Okay. So that is what is showing. Then I will pop all the elements 11, 24, 13, 15. Okay. So we will pop all the elements. So it will be like this. Now top is at the last position. You pop that one also. So after popping that element, so now top is at -1. Top is -1. Okay. That means no element is there in the stack. Okay. If you are trying to delete an element now, so that means you will be getting a condition called underflow. As there are no elements in the stack, it will be showing it as underflow. Okay. So see here, if I'm trying to apply pop, so I'll be getting something called underflow condition as top reached to top equals to -1. Okay. So that is about array representation of stack. Okay. I hope it is clear. Stack is nothing but it's a linear data structure where insertions and deletions takes place at one end. Okay. So insertion is called as push and deletion is called as pop. Okay. So now we can represent stack using linked list also. So how we are going to represent? Observe here. So linked representation. We can represent a stack as a linked list. What do you mean by linked list? I already told you linked list is nothing but which consists of nodes. Okay. Each node consists of two parts. One is information field and the other one is address field. Okay. So in information field, we are going to store the information or data. In the address field, we are going to store the address of next node. Okay. Address of next node will be stored. Okay. We'll just use that linked list for representing this stack here. Okay. Observe here. So starting 10 element is there. So then I push one more element 20, then I pushed 30, then I pushed 40. Okay. First, so if nothing is there in my stack, so it is empty. So then top comes to here. Okay. Then top comes to here. Then top comes to here. Then top comes to here. Okay. I'll be just moving. So here I am storing the address of next node. Here I am storing the address of next node. Here I am storing the address of next node. Okay. In this way, I am going to represent the stack. Okay. So stack can be represented either using arrays or it can be represented using linked list. Okay. What are the applications of stack? Where I am going to apply these stacks? So stack. So I can use stack in various applications, various places. I may observe these stacks at various places. So if it is not computer terminology, if you observe, when you are placing a tray of when you are placing trays, okay, one by one, then if you observe, we'll be placing a tray. On the tray I'll be placing another tray, on the tray I'll be placing another tray, something like this. Okay, whenever I am trying to remove, I'll be removing the top element. Is that clear? Okay, so that is generic example we can give for stack. Let's see where we are implementing this stack in computer application. Okay, so if you observe here, so I have given a lot of applications. We'll be seeing these applications in another session. So anyhow, I will just brief about these things. So stack is used by compilers to check for balancing of parentheses. Okay. Now, while executing your program, you may observe flower brackets. You are opening flower brackets, you are closing flower brackets. Okay. So, how many number of open brackets are there? That many number of closed brackets will be there. Okay. So, who is going to count it? We are not going to count it. Okay. System itself dynamically doing. How it is going to do it? So, it is using this application. It is using this stack. Okay. So, whenever an open brace is observed, it will be placed into the stack. Okay. Whenever we see a closed base, we'll remove or we'll pop that open base from the stack, so that we are matching opening braces with closed braces. Okay. If both are same, opening base and closed base are same, nothing will be there in the stack. Stack will be empty. If something gets wrong, suppose if there are 3 open bases and 2 closed bases, at the time one brace will be there in the stack. That means it is saying that your program is wrong. Okay. So in this way, I can use stack for parenthesis matching or brackets matching, braces matching, all these things. Okay. Now, similarly, I can use stacks to evaluate a postfix expression. Okay, we all know expression. What is an expression? Expression which consists of operands and operators. Okay, how we are going to calculate these operands and operators? So we are having a mechanism. We are using a stack to evaluate these things. Okay, so I can evaluate a postfix expression. So stack is used to convert an infix expression into postfix. Okay, similarly, I can use the stack for recursion. So whenever use the recursion is nothing but function calling itself. Okay, so there also I'll be using this stack for storing my address. So returning address, I'll be returning function. I'll be using this stack. Okay. So during function call, the return address and the arguments are pushed onto a stack, and on return they are popped off. Okay. So similarly, depth first search. While implementing depth first search, I'll be using this stack data structure. Okay, to find an element from a graph. Okay, we'll see all those things clearly in the next session. So as of now, just see the various applications where we are implementing this stack. Okay. Uh, okay. Thank you.